All right, everybody good?
Yeah.
All right. So, copy this down. Charles Law, what we're doing today.
What's the title?
Charles Law.
Okay.
Charles Law says the volume of a gas is directly proportional to the temperature of a gas, at a constant pressure. So yesterday we were inversely proportional, correct?
Yeah.
So what does that mean? What does inversely mean?
One goes up, one goes down.
If one goes up, the other one goes down. So directly proportional means
If
one goes up, the other one's going up. If one goes down, the other one goes down. And I'm sure those are terms you've heard before in some sort of math class. Yes, no,
Yes.
maybe. Okay. So, if we have a volume of a gas at a certain temperature, we know the pressure inside is equal to the pressure on the outside, right? Because we have a flexible membrane, so generally it's the same. We also know that if we increase, the volume can increase by stretching out the balloon, right? So if I heat the balloon, I'm heating the gas inside of it, so the balloon will expand. Okay? So as the temperature increases, so does the volume. And it's proportional. So they increase not necessarily by the same amount, but relatively, yes. Can y'all see it getting bigger? Yeah. It's not, the water's not real hot yet, so it's taking a little bit longer. It's getting bigger. And I'm out of ice, but the water's still pretty cold. So I'll put it back in the water, it'll begin to shrink. Back to where it was. Make sense? No. So yesterday in Boyle's law, we multiplied, right, in our formula? So since it was inversely. Since it's directly proportional, we divide. So you have your starting volume over your starting temperature equal to your ending volume over your ending temperature. And all the temperatures have to be in Kelvin. Why?
You can't have negative.
Because you can't have negative numbers, right? And 0 Kelvin is the coldest you can ever get. Correct?
Absolutely.
Correct. All right, so and that's over there is how you convert Celsius to Kelvin. You didn't get that yesterday. Celsius plus 273 equals Kelvin.
We need to write the other stuff.
This will be the example 1 on the paper, so just hold on. Any questions so far? Pretty straightforward, right? And you're just going to solve that by cross multiplying if you're not algebra smart. Can you say that's you or?
This is like, this is the same thing, isn't it?
Yes. Whatever your brain works.
Yeah, that my brain.
I don't do that because it sometimes confuses people.
I just feel like this way.
Because that's basically doing the cross multiplication ahead of time.
Yeah.
Isn't it the same thing we did yesterday?
All right. So number 1 says calculate the decrease in temperature when 2 liters at 20 degrees Celsius is compressed to 1 liter. Excuse me. So starting volume is 2 liters. Starting temperature is 20 Celsius, which is 293 Kelvin. Final volume, excuse me, is 1 liter, and we're looking for the final temperature, right? So you put it into your formula, 2 liters over 293 Kelvin equals 1 liter over T2. That solves for T2 is 146.5. But is that what we're asking is the final temperature? Is that what it asked in the question?
Calculate the decrease.
The decrease. So what do? Subtract. Ends up being the same answer because 146.5 is half of 293. So it didn't make a difference. And I wish they would have done that on this worksheet, but yeah. It's kind of a bad example for doing that. So it ends up being the same. But your change, your decrease, is 146.5 Kelvin.
So we need to highlight each one.
Well, you don't have to have that. I put it on there so you can get your brain kind of around what we'll talk about. I'm not going to count off if you don't have that. Just 146K, 0.5K. The biggest problem kids have had today is remembering to convert your Celsius to Kelvin. Okay? Don't let that trip you up. Also, be sure you read the question and do what it's asking for. Because like on number 4, it says, what change in volume? So you have to subtract there, right? You're starting from your ending. Any questions? All right. Do it at the beginning of the period tomorrow. Get after it.
Can you do the